This house painting scenario is a standard problem in many algebra textbooks. Students often learn to plug and chug the given values into the product over sum formula, A times B over A plus B, where A and B are the two rates that the house painters paint. Most students have not painted houses. They lack any real-world applications that could make the formula meaningful in their lives. In How People Learn, Bransford discusses how learners move from novice to expert. He describes how experts, by gaining extensive knowledge, learn how to organize, represent, and interpret information. These skills affect learners' abilities to remember, reason, and solve problems. In order to provide an inquiry-based, student-centered approach to the product over sum formula, circuits and resistors are introduced. Each resistor represents the time it takes an individual worker to paint. The total resistance for two resistors in the circuit is equivalent to the painters working together, i.e. in parallel. The circuit inquiry is designed to encourage the development of expert learners. To fully explore this activity, the students will need a few basic circuit essentials. As the base of the circuit, students will need a breadboard to build their assembly on. The breadboard used has 300 ports and lacks the need for soldering. This allows for easy insertion and removal of electrical components and is completely reusable. Next is the battery pack that will supply power to the circuit. This holds 4 standard AA 1.5 volt batteries. Purchased from any electronics store was a small 6 volt buzzer and a red LED light. Next, to ensure that the LED functioned properly, resistors were used. In particular, resistors with 5 different ohm values were utilized, including 220, 330, 560, 680, and 1000 ohms. Lastly, to correctly measure the resistance of the circuit, a multimeter was used. To start this activity in the classroom, a simple yet effective circuit demonstration will engage the students. It will involve the breadboard, battery pack, and buzzer. By connecting the buzzer and the power source through the breadboard, a simple circuit is created. The buzzer will make a noise when the power switch is turned on. During the exploration of the activity, students will be encouraged to build a circuit that will light the LED. The battery pack will be attached to the breadboard, followed by a resistor, the LED, and then the ground wire of the battery pack. A handout with illustrative instructions will accompany this exploration to help minimize confusion and maximize discovery. Students will be able to judge their success on whether the LED lights up. Once the students are successful and the circuit is complete, they will also be using the multimeter to measure the resistance. This particular resistance settled at 986 ohms and will be recorded in a table on the handout for reference during the explanation phase. When the students are able to successfully light the LED using one resistor in the circuit, they will then consider 2 resistors working together in parallel. After they have measured each individual resistance in the system and recorded on the table, they will measure the resistance with both resistors and develop an understanding for the concept. Students will investigate this with several different combinations of resistor values. They will be able to conclude that the total resistance of 2 resistors in parallel is less than either of the individual resistances working alone. During the explanation, students will be looking at their gathered data and making inferences about the resistance changes. They should be able to describe what is happening in the circuit when 2 resistors, as opposed to 1, are involved. Students will develop the total resistance formula of the circuit and confirm that it accurately calculates what they measured with the multimeter. During the elaboration of the lesson, students will be introduced to the house painting scenario. They will be asked to solve it. When at first they are unable to answer, they will be reminded of the circuit system and how the resistance reacted. Students will be encouraged to see the similarities between the change in resistance to the change in time for house painting. They will conclude that the resistors can simulate the individual painter's time and that when working together, the painting time will decrease as did the total resistance of parallel resistors. With this inquiry, there are challenges that both students and teachers will face. The first challenge will be using the experimental data to derive the formula. When considering the resistors, there must also be attention to the tolerance of the resistor. Most resistors will have a 5 or 10% tolerance. This challenge can be overcome by knowing the theoretical resistance and the tolerance of the component. Conceptually making the leap from the circuits to the house painting problem may also be a challenge for some students. Implementing this teaching technique in the classroom has several positive features. The activities involved are student-centered and inquiry-based to develop expert learners. Also, because of the content, this lesson could span several disciplines including algebra, statistics, physics, and engineering. With this lesson, all materials are reusable and therefore the majority of the cost is one-time and can be seen as an investment. On the other hand, there are a couple of disadvantages to teaching this inquiry-based lesson. The first drawback to this activity is the time involved. This activity is developed to span 2 days. 2 days is somewhat of a long time to teach one formula. Even though the materials involved in this lesson are an investment, there is still the initial cost to consider. Lastly, if this is kept in a math classroom, there will be prep time to gain understanding of circuits.